Hi, I'm super stoked to be here. I'm really enjoying Philly. I didn't understand the gritty thing until now. I get it. This city's edgy, and so am I. So we're going to talk about functions today. I avoided putting the buzzword on the slide, but I'm going to talk a lot about serverless. And serverless means a lot of things to a lot of different people. Actually, I'm curious, if you're using AWS Lambda, just put up your hand real quick. Okay, that's a lot more people than last year. If you're using Azure functions, okay, Microsoft in the room. Kubernetes? All right, put your hands down. It's not serverless. It's not serverless. All right. I had to. So you can just yell at me. It's cool. What's the number one problem with serverless? We got some serverless folks here. Just yell it out. Orchestration. Money. I guess, yeah, it is a problem. If you scale infinitely, then you're bound by your credit card. Any other major problems with serverless? No cold starts? That's cool. Oh, yeah, cold starts. That's one. OK, well, I would postulate that the number one problem with serverless is that no one cares. No one cares. People are on Twitter talking about this all day long while you're shipping. You don't care. And I think the thing is that no one cares yet. We've got really good tools now. Doing the things that we used to do 10 years ago is just not really on the radar. We commit code to GitHub and it runs through continuous integration, and magically a zero downtime deploy happens and your code's there, or maybe it canaries over. These tools are very good now, and we're starting to do something I've never seen before in software. We're starting to have successful projects, and it's amazing where we're getting. To me, cloud functions represent the most pure idea of the cloud abstraction. So when you think about what a server is, it's like a metal rack that you used to have to push into the back of a thing, and you'd get a whole bunch of like cables, and you wouldn't label them because you didn't have time. And then you'd get another rack, and that's how you scaled. And we somehow decided that that was the metaphor for our applications, this metal rack with unlabeled stuff. And it's not really. A better metaphor would be your app itself, or maybe the components of which it's composed of. And Amazon had an accidentally brilliant idea that they could bill you every 100 milliseconds for a function invocation. And this makes the function the deployment unit, which is a really big deal and a huge change to how we can architect our apps and how we can think about deploying our apps. I just want to point out, too, that the function is the unit of deployment, not your entire app. And that's a really big deal also. When we're deploying these monolithic apps, it's an all-in situation. If there's a bug anywhere in that app, then all of that app is hooped. And I also want to point out that when you build serverlessly, you do not want to put your whole app in one function and deploy that. I've done it. Everybody does it. Everyone does it. Everyone's like, you know what? This thing scales infinitely. Fuck it, I'm putting Express in there. Upload it, and it works. It works really well because it's a hello world. The thing is, with a monolithic app, it doesn't get smaller. That's not a property of monoliths. They just get bigger and bigger, and as it gets bigger, so does your cold starts. Cold starts is a situation when the container, or the VM of the runtime, is being started for the first time. And Lambda is built on a technology called Firecracker, which is in the lab seeing about a 10 millisecond cold start. And then there's a whole bunch of other cloud function stuff out there that is not that fast. One thing that is common across all of these cloud function providers, the function cold start is directly correlated to the size of the function payload itself. Bigger the function, longer the cold start. So how do you defeat cold starts? Lots of small functions. This talk is largely about AWS Lambda, but I think a lot of this stuff applies broadly anyhow, if you're using other technologies like Azure functions or GCP functions. Lambda's got some pretty nice characteristics, though. So the first thing that I think is probably the thing a lot of people talk about is the money thing. Cloud people call this 100% utilization because it sounds confusing. I guess, I don't know why. But you only pay for what you use. The other nice way to call this is scaling to 0. And so when your function's not being run, you're not paying for it. You're not paying for provisioned resources that you're not going to need. If your function executes in 100 milliseconds, that's what you pay. This is debatable. If there's any OPSEC people here, I'm certain I'm going to get roasted for saying this, but I think it's a better security model because you have better isolation points. And you can choose those isolation points and lock them down very specifically. So the principle of least privilege is we don't want our application to have access to stuff it doesn't need access to. And with functions, we can actually take each function and give it different permissions. This can get out of hand. If you had 300 IAM roles for one app, that might not be the best scaling idea. But it's nice. So you can do things like blanket policies. All the GET requests can only read from the database. They can't write to it. The other nice thing about this security model is there's no ports to scan. The code goes away. It's totally stateless. When it's on, and when it's off, it's off. This is just a nicer model. If you're building a monolith, your least privilege is the most you can do, which is not very minimal, depending on the monolith. This is big. So now we can focus on our business logic and deploy our code and not have to think about how we're going to scale it, how we're going to manage it. We just put the code up there, and then in theory, it runs forever, bound only by your credit card. By the way, the free tier is pretty generous. For AWS Lambda, I think you get the first 1 million executions for free, and then it's 10 cents for every million after that. So 10 million executions for $1, roughly. So it's not free, but and my credit card is definitely not infinite, but there's a lot of room there to focus on business value. So to me, functions as a service is the best in class. You have fixed costs, you get better security, and you get faster iterations. But the real big thing here is that these things are faster to deploy themselves. And so what do I mean by that? A bunch of little functions. By the way, people are like kind of definitely squirming when I say a bunch of little functions. Your app has a bunch of little functions already. You just don't have any isolation between them yet. And that's something to be aware of. So why is it a big deal? One function deploys in about 2 to 3 seconds, depending on how big of a payload it is. And what's nice is you can deploy them all in parallel. So as your app grows, your deployment time stays the same. And your iteration time is vastly improved. 2 to 3 seconds to staging is unheard of. This is better iteration speed than we've ever had as an industry in the past. Better iteration speed is better feedback loops. Better feedback loops is better chance you fix that bug and go home at 5. Better chance of finding product market fit. Better chance of beating your competitor. It's kind of all about speed. Author time is faster. Your runtime is smaller. And your bug resolution is actually a lot easier. This is a subtle one. We split up our functions on a per route basis. And we realized that this isolation gives us really good debuggability. If there's a problem on /login, then that's where the problem is. Because, right? Whereas in a monolith, if there's a problem on /login, get grep out and start looking through logs, because who knows? It could be anywhere. So it's faster to read, write, and fix code, which is something I try to do. So I'm going to do some live demoing here. I'm not going to do it in a sport coat, because that'll just freak you out. So I'll just put on my hoodie. I'd put on the headphones too, but that'd be really awkward. So I keyed up a little bit of a demo app you might have seen earlier. And I didn't want to bore you, but you can see the runtime of it. Oh. You can also see I got a rate limit error. It was about 3 minutes over the conference Wi-Fi to kick this thing up. But let's just take a little look around here. All right, so we use, support, work on, and promote a project called Architect. There are many ways to do this. There are many frameworks. This is just the one we're using. So this stuff is applicable to other frameworks. Arc has a manifest file called .arc, which people think stands for architect, but it doesn't. It stands for Amazon Run Commands. We wanted to have a cool RC file like Vim, so we're like, Amazon Run Commands. And then we donated the source code to the JS Foundation, and they're like, Amazon Run Commands is a bad name for a project. And we're like, that's true, so we called it Arc. The Arc file format is very terse. So @app is declaring a namespace of Philly. @HTTP is defining 3 functions. And I'm just going to nuke my source here. And I'm going to run, whoa. I'm going to regenerate our local source code. This will take like a few seconds. If I pop over to the file system, we can see what the fresh functions look like. Is this reading OK? In the back? OK, cool. All right. So it looks terrible because it's JavaScript, not because it's Cloud Functions. And I'm sorry about that. It's just how it worked out. No one's happy. So, hi, Philly. So it's pretty clear what's going on here. We're going to respond to an HTTP request with hi, Philly. Let's deploy that. Oh, God. That's how you know it's a real live demo. Cancel missing lock. Oh, you know what? I think I know what that was. All right. NPM added lock files recently because they decided that determinism was a feature that we might want in software. And I think they changed the behavior of how it gets created. As soon as this is done. Oh, I bet it just finished. No. Repo. Oh. So let's just see if there's no lock files. That was the problem. There's lock file, there's lock file, there's lock file. I have no idea what the problem was. Let's just try and deploy. It's just npm acting up. OK, great. Let's just see if it worked. Oh, that's right. We got to modify it first. All that hard work for nothing. I used to say never live code. Now I just do it. Why not? Philly, great. So that was unnecessarily long, almost 1 minute to staging environment. We don't want to just do staging. We want to do staging at production. So let's upgrade production, which is 1 command away. And this is pretty dangerous stuff, right? Like being able to get to production this fast. You probably actually want to put this behind some kind of CI. But there you go, 2 totally independent URLs of a function deployed. So let's make this a little more interesting. I thought we could do like a little CRUD app thing. And I'm going to maybe need your help, so just yell at me if I'm doing something wrong. So start off, let's register a Slack app really fast so I can get some tokens. We'll call this Philly beginners. So Slack's UI is a little bit confusing, but they got this OAuth and permissions thing. Well, we'll put in redirect URLs. Has anyone here implemented OAuth before? Yeah, you're all like, are we going to go through this? We're going to go through it. It'll be quick. It'll be quick. I know. So I'm just going to jump out of here for a second. Grab the staging URL again. We'll copy it. So OAuth is using somebody else's identity, or using your identity through someone else verifying that you are you. That probably didn't make any sense. We'll just save that. And so we're going to get an add to Slack, or a sign in with Slack button in a second here. Oh, that's right. I got to add permissions. So scopes is OAuth's way of saying what permissions I get. And I mostly just want identity permissions. And they're going to try and scare me into not using them. We'll just ignore that. Give me all your permissions. Save those changes. Did that save? Okay. Great. So then they give you this thing, which is like the add to Slack button. But what's funny, I emailed them about this today. The text area is disabled. So I'm just going to use dev tools to copy that. It kind of makes you feel good knowing it's like this everywhere, though, right? What is this company worth? $10 billion or something? Like, you can feel good knowing that we're all just doing the best we can. OK, so in a real application, you may want to put these variables into environment variables or somewhere else. We've got this client ID here. That's kind of gross. It would definitely be a better idea to not hard code it, but it's a demo, so whatever. I also would like to point out that that client ID that Slack generated is a giant integer, a giant double, and I don't know if you know much about JavaScript, but it's not actually that good at math, like at all. And so if I were to, let's just do this, it'll be funny. We'll deploy it first, and then I'll show you what I mean. OK, whoops. OK, so we're going to throw that up in staging. Oh, and I'm deploying all three functions. But I don't have to do that. I could just deploy one. And if I was just working on like one part of the system, or we had some devs on one team and another team that could divvy up the work. As you can see, it saved a huge amount of time. So this is definitely an efficiency gain. So we get this big, old add to Slack button. If we click it, Slack's going to be like, yeah, this person is them. Authorize. And we come back and we get a code, and it's pretty useless. We can't do anything with that just yet, but we will. I'm just going to quickly inspect that element and show you what happens to large integers with JavaScript. So, oh my God. Come on. MacBook keyboards. So if we went into Node, it's OK. JSON has a solution. I'm a scientist. OK. So we've got this button, and we click the button, and it takes us to Slack. Slack says, yeah, that guy is who he thinks he is. Here's a code. And it hucked me back at the login page. And so in this login page, we're going to take that code, and we're going to exchange it for a token from Slack so that we can log it. This is the OAuth flow, as it were. To get that, we'll need to read the URL. So I'm just gonna do something really lazy here. This is getting a bit out of hand, I know. My code's not the best, but it is kind of realistic interpretation of JavaScript development. OK, so let's just take a very quick look at that request object that gets passed through. Oh, am I? Oh. Oh, well, we can just look at the index page. It's OK. So that's that request object. Thank you, though. Please do not hesitate to point out my failures as they happen in real time. I'm a big fan of pair programming. So if we You can see if we change this, we'll get different query params. Obviously, this is kind of table stakes, but believe it or not, most of this is not baked in. You have to set up API Gateway to do a lot of this stuff, and it can get kind of complicated, but it's already here for us, so that's sweet. So if request.query.code exists, oh, this won't even be on this page, actually. This will be on the get login page. So I'm going to clamp all this junk. So if there is a request.query.code, we're going to call into Slack with it and get a token. We could do a raw HTTP request, but I'm guessing nobody wants to see that. So I'm going to go to my trusty friend npm. We're going to install the Slack client library just into that one function. So we're not installing it globally, we're just installing that one function. And it's let, I don't know, we'll just say result equals await slack dot, I can't remember. That's funny. But I'll find out real fast. Slack OAuth dot token. That's the one. I think. So this thing needs a client ID, a client secret, and the code that we were just given from Slack. So we're going to give it those things. We're going to hard code this. Again, you would probably put these in environment variables. That's why I'm quoting it. Client secret. Okay, don't tell anyone. I like how they do this. Just in case. Whoa, what the heck? Show. Thank you. All right. Now you're all just rushing out now to log in maliciously to my nothing app. So that'll just give us some result. Actually, I'm not even going to put this on there. I'm just going to take you off. And we'll just fail ugly if things are wrong. JavaScript's got this neat thing called string interpolation, which is really great for debugging. That was a joke. Everyone's like, I do that. We all do. OK, cool. Great. So in theory, I'm going to load that button. We're going to click the button. We're going to go to Slack. Slack's going to say, I am me. It's going to redirect us back. And we're going to get a payload with that token, probably, unless I screwed something up, which, you know, happens. Invalid code. Actually, that's cool. Interesting. Let's try that again. Yeah, that's definitely an invalid code. Cool. All right. Well, the demo gods have been unkind. We got a request.query.code. Oh, wait, did it redirect back to /login? Yeah, it did. Let's see. That is not valid. Whew. I love that when that happens. This totally worked like an hour ago. Let's just keep moving then. So let me show you a few other things that we can do with this amazing technology that is Cloud Functions. So I'm going to add a shared layout. This is, oops, I put that under HTTP. This is pretty common. to want to share dependencies across multiple functions, and something that you're going to need to do. So we baked that in. And I bet you think I'm going to do something really nice here, but I'm not. Hi. OK, so that was long-winded. Go back to index. We're going to grab that layout. Whoops. So every time we deploy, we actually refresh all of your dependencies, including the shared folder. And this gives us the ability to share code across functions. This also means that anything you share could break everything. And so you got to watch out. But that's no different with like anything or any kind of monolithic app. And it turns out that these are actually pretty rare in larger apps. And by larger, I mean some of the bigger architect apps are pushing around 300-400 functions, which also still deploy sub 1 minute. The shared folder tends not to be that busy. You put some logic in there, but yeah, shared folders. So I kind of want to go back and try and get that working. Why don't we do some debugging and look in the console at what we get back in the payload?
What was the client ID?
3.7. I got that actually out of the there. Yeah, it looks right. It's saying the query code is wrong, so maybe we log that. We'll log the whole request, and we'll log the result. And actually, we'll format this nicely, too. Null2. And now that I think about it, the other thing that we should be doing is wrapping this whole darn thing in a try-catch. Oops. Pop you there, pop you there, and we will log E if we get that. All right. Totally realistic JavaScript programming. So we're going to deploy this. We'll try and walk through it again, and then we'll read our logs, and we'll see what we see. Maybe we can figure it out as a team. If not, it's all good. Oh, I got rid of my button. Well, that was dumb. Whoops, not deploy. One thing you maybe are noticing, though, is that we've got pretty good iteration speed. And we're just cruising, moving fast, not changing production, hitting staging pretty quick. And that's kind of nice. Failing in front of a large crowd, not so nice. But the iteration speed of the failure is pretty nice. OK, so to get the logs, there's a command for that, of course. We could sign into the AWS console and try and find these logs. It's not a very pleasant experience. Oh, right, get index isn't the problem. Invalid code. What a nebulous error. I wonder if I should just create a new one. Or maybe compare to what they got. I think that thing's valid. Maybe I have to install this in my workplace. That's possible. Let's just see. Oops. Sorry?
Don't you love whole auth?
I know, yeah. Usually I do. Yeah, I don't know what I have done there. That's a good question. Are the scopes okay? It's saying the code's bad, or it's saying not this. It's saying request.query.code's bad. So maybe we should log that.
Result isn't in scope. In your return, result isn't in scope.
Yeah, yeah, that's true. Thank you. All right. Let's just deploy everything. We got time. Something else I have failed to show you was that we didn't have to deploy any of this. Everything about Architect also runs offline and locally. So should you wish to have a local development experience, it also runs headlessly. So if you want to test, you can test without setting all that up. To my knowledge, no other serverless things do this. They have plugins to do it, which is the same as not doing it. They'll be like, yeah, use a plugin, which is like, go F yourself. OK. Get login. Local dev is pretty key. Results not defined. Invalid code.
Did you hit it?
Oh, I don't think I did it, no. 1 sec, let's clear these logs. And then we won't do this local. Whoops, whoops, whoops. Philly, here we go, back here. Great. I am me. Nope. No logs. I kind of expected that, actually. So another characteristic of the cloud is eventual consistency, which means your logs don't show up for a few minutes longer than you want them to. There we go. So invalid code. And what do we got here? Request.query.code. Oh, is it just me, or are they concatenating our client ID onto the code in the return? Are they? It's just some rando value. 37193. 37193. OK. Huh. Oh, man. PHP app for OAuth interacting with a JavaScript app. So what I'm going to do here is I'm going to take that code. Oh, no, I'm not going to take that. I want to replace it with the client ID. So we'll just take our hard-coded client ID, pop that up here. I have no idea if this is going to work. This is funny. The dot. Oh, is there? Shit. OK. Oh, man. I love it. OK, we're going to deploy this. And we'll see. I'm kind of determined to get this working now. You're going to walk by in a couple hours, and I'll be like outside, like, fucking thing. Someone's going to tell me I should have used TypeScript. No, it was a long shot. I am curious, though, to see if we got different logs out of that. I mean, is it just me? Yeah. Well, that is just not that great, but that's OK. We can still do a little bit of a cruddy app. I think I've got time for this. So we're not going to have authentication, which really bums me out, because I wanted to show that to you. All right. Let's keep going. So if you're doing a cruddy app, you're going to have form posts, and you're going to write to databases and read from databases. So we're going to do some of that. I set up an endpoint called cats. I like cats. Equals post. And we'll just do like input type text name equals name. Your cat name. It's kind of like React, but it's just HTML. And it's crazy because you don't have to wait. You just deploy it. So if we look at post cats right now, it's not doing much. It's just going to render high. But let's go take a look at that. Oh, no. Sweet. Oh, URL's not defined. Yeah, that makes sense. So we have a helper. You probably noticed that API Gateway gives you these really nice URLs. And they help you out by adding like these folders at the end, which is sort of annoying. So we have a helper function called URL to get rid of that. So I'm going to do this. Deploy. The thing I really kind of wanted to just demonstrate, though, overall, was that you get fast iteration speed. As a result of that fast iteration speed, you get more chances of not embarrassing yourself in front of a large group of people. OK, so we got a form, cat name, save. It goes to high because there's nothing going on there yet. Let's add a database table. So the ARC file format is pretty forgiving. Just name string. npx create. Actually, I'm going to save myself some time here and cheat. So ARC only creates things if they don't exist, which is how most of these things do. And Jesus, that was fast. Did that work? Oops. It worked. So believe it or not, we just created a database table called cats. And when we post to cats, we'll add a cat to cats. I really wanted to put this behind a login. So I guess now everybody can just add cats willy-nilly. To location is URL / oops, don't forget to add URL, arc.htp.helpers URL. So all this will do is just redirect us back home. Actually, let's test that. That's fine. Seems like a reasonable thing to want to test. Here. So yeah, we're redirecting. Great. Just to prove it, because that is so damn fast. You can see here, by the way, our cold starts are pretty OK. Definitely could be faster. There's milliseconds to shave, absolutely. But generally, Lambda functions should cold start within 200 milliseconds. Once they're hot, 50 milliseconds. That's a big deal. So adding a cat, that's not going to do anything. So we're going to go here. And for now, actually, let's just dump out. Well, how do we do this? Data.cats.put body. How about that? Oops, we got to await. So arc data reads the arc file, so it knows that there's a cats table, and it generates a little ORM thing for you. You don't have to use any of this. You could use whatever you want in the Amazon ecosystem. This is just putting you on Rails. It's going to be fast. If you want to make it harder on yourself, you can do that. We've done all the homework, and this is the fast way. So that didn't fail, but we can't see anything. So let's visualize our cats. I like how this metaphor just keeps getting creepier and creepier. Visualize our cats. All right. So, funny story. DynamoDB has 4 ways of querying. You can get an item, you can query for items, you can batch get items, and you can use scan. Never use scan, but I'm going to use scan right now. So scan will walk through the whole table, and it can take forever, and it's just completely inefficient. But we don't have that many cats, so I think we're going to get away with this. Okay. We'll deploy that. Yeah, that was a slow deploy. Whew, 7 seconds. What a waste of my time. So there you go. They're the 2 cats that we wrote into our database. None of this is deployed into production yet, so let's upgrade production. No cats. Also no form. I overwrote that form. Let's add that to the front of the line here. This is just terrible code, I know. It's kind of not the point, though. It's like, even if I tried really hard, could I make JavaScript look nice? I mean, people have been working on that for years. It's to no avail. Oops. Hello. There we go. Oh, let's try production. npx deploy production. The nice thing about DynamoDB is it guarantees you single millisecond latency. So you can only read 1 megabyte at a time in a millisecond, though. So if you need to read 10 megs, it'll take 10 milliseconds. Ish. The other databases have a lot of problems with the serverless world. They're not designed for this situation. You can swim upstream and kind of get them working, but the cold starts are terrible and connection logic's bad. So that was a cold start that just wrote to the database and redirected back. Did you see the page reload? I mean, well, my cat's name is Sutro. And we used to have one named Blackie. There you go. So that would have been behind a login, but is roughly my demo. So I'm going to put my jacket back on. No, I won't do that. So there's a lot of ways to do this stuff. And I want everyone here to understand that I'm not telling you this is the way. You can experiment with serverless framework. You should experiment with serverless framework. You should check out Cloudea.js. You should try doing this stuff with Java and Kubernetes and Knative. All of these characteristics are now possible. And they're possible in a whole bunch of different ways. And you don't have to do the JavaScript thing if you don't want to, and I totally understand if that's the case. If anyone is telling you they know the way to do it, benchmark them against this thing and see. The other thing I think is really interesting about what's going on now is the back end is suddenly accessible to anyone that wants it. We could all spin up a Rails app, no problem, but scaling that thing traditionally has been a heroic effort for lots of engineers. Now all of this capability is available to you, and you're only really bound by your credit card. I think this means dev teams get smaller. I think this means iterations get a lot faster. And overall, I think we're going to just be plain happier doing our work, which is quite cool. The project that I was using all that time is called Jsf Architect. They just rebranded. They're now OpenJS. So great. We like pull requests. We're getting quite a few of them these days. Also want to say, by the way, you're allowed to like bug reports are really appreciated. Like I'm never going to be mad if someone sends me a bug report. I've met people and they're like, oh, we tried out Arc, but it had a bug, and I didn't want to tell you. And I was like, what? Like that is a total dick move. Like, please tell me. It's cool. Feature requests are also appreciated. Our use cases aren't your use cases. I don't know how you want to build your apps this way, or if you even do want to build your apps this way, but there are a lot of advantages to doing it. And please share all of this stuff on the Twitters and on blogs, and tell everyone that it's out there and it's available. All of this was open source. There's a quick start on arc.codes. Quick pitch for my company. We do CI for our serverless stuff. We're in beta right now. And yeah, sign up for our beta. And I think that means that I'm ready for the Q&A portion of this situation, which means I change to not this. So Philly is cool, by the way. And I don't know if you know this, but you have a Marvel exhibit at the Franklin right now. Anyhow. If you want to check that out later, I think I am. Let me find, what is it? There it is. So I think you go here, and this is where you can start asking questions. You could scream them out at me, but it won't be captured by. Yeah.
So if the authentication was working, how would you protect that cat's endpoint?
Right. So if the auth worked, I would have saved the auth token in a session variable called logged in. And then cat's endpoint, I would have said, if logged in, cool. If not, you're out. And that's basically how all session store authentications work. There's kind of this weird thing being pitched these days that you should outsource this to other companies. I think that's really weird. I think it's fine if you don't want to build user auth, but if that was working, it would be like 30 lines of code, and you would own it. You would own your user data. Yeah, I don't know. I don't think integrating with these things is necessarily the best path. Cool. So does serverless work with ORMs? How would validation against a model work with an RDS if each function is invoked on the fly? So it does work with ORMs. There's a thing called serverless Aurora that lets you do Postgres from within Lambda functions, and it works exactly the same as it would normally, whatever normal is for you. The problem with Aurora right now is I believe it's got a VPC requirement, so you have to be running in a VPC, and Lambda functions that run in a VPC cold start a lot slower, like sometimes a couple seconds. This is generally okay for a lot of app, and that number is just going down. So when people are concerned about cold starts, when I first started doing this Lambda stuff in 2014, they were above 3 seconds. And you've seen how fast it is now, so it's only going to get better. How does it integrate with CI and source control? This stuff's new, but it's all CLI based, so pretty easily. We have a product that we're going to sell that makes it even easier, but currently we use CodeShip, and we have scripts. Just bash scripts that run those same commands that you saw me running on the command line. So that's that. Should I be clicking these, uploading these? OK, after clients authenticate, how do you main the session? So we set a cookie. And we also have the ability to not set a cookie, and you can use database back sessions if you want. It's using a JWE, which is a new fancier version of JWT. It's encrypted. It'll be fine. So that's how we maintain session state. Under what circumstances will one go back to a cold start? If you build monolithic functions, you're going to feel cold starts. So as soon as you start adding dependencies, it's going to get worse and worse. And you can test this out yourself. Throw like a big MP3 in a function. Don't even use it. Just have a big file in there. And then when you load it, you'll feel that cold start. The magic number we've arrived at was 5 megabytes uncompressed. And some front-end developers don't think that's a lot of room, but I kind of feel that that's a lot of room. You can build a lot of app in 5 megabytes, so your mileage may vary. Can you go into the API gateway setup for a simple app like this? Yeah. Let's do it, if you want to see it. Let's reload the page. So this is what we were looking at. This is the AWS console. So I'll start from the beginning. I would say that this is kind of like looking at the front cockpit of an airplane. So you have all these services available to you, which is cool, but which ones matter? And where's my app? Like, turns out it's all over the place in here. But API Gateway is kind of our key Lambda invoker. And the thing we were building was Philly, staging and production. If I zoom in here, you can kind of see, maybe I can increase the font size. So I don't know if you can read that, but each of these are the routes that we generated when we created this application. And each route has Lambda functions bound to it. If you wanted to set this up yourself, like manually, you could totally do it. So here's where we put in the Lambda function, and this is the region it's in. And then there's these friendly things called mapping templates, which you have to define for every type of request and response that you want to handle. Maybe you're familiar with the friendly language velocity. And so I don't know if this looks, it won't let me expand it. It's a really nice little editor. As you can see, it's something. If anything, this just really demonstrates to you why you want to use a framework. You could do all this, and we did in the beginning, but we eventually baked it all into Architect. These are the response. So in the response, we have a mapping template that lets us do all the fancy stuff that we do. And then this is a bit of a weird one. A lot of serverless apps just have this at the root. It's called Proxy Plus. This is a catch-all. And so if there's any 404, it'll just bump back to the index for us. This is a pretty common pattern with front-end apps where index HTML will just handle everything. And if in our world, we want to do that because a 404 in API Gateway is actually a 403. But if we have proxy handle it, then we can handle the 404. It's annoying, I know, but it's just how it works. You got to have something handle it, right? And if the function doesn't handle it, API Gateway doesn't know what you're asking for. And so the right thing for it to do is to say 403. I think that's the main hits of API Gateway. There's also settings for doing things like binary encoding, for uploading and downloading files. It's a pretty comprehensive user interface. I was trying to think of like the most politically correct thing to say there. So yeah, that's the API Gateway setup. We haven't shipped this yet, but we actually have CloudFormation export coming. So you'll be able to take an Architect app, export it as a CloudFormation template, and then redeploy it wherever you want, however you want. And people are like, why didn't you support CloudFormation at the beginning? I wanted to. It didn't support Lambda at the beginning or API Gateway. So yeah, we had to do hacks. Would you use Lambda versus Fargate? I wouldn't use Fargate, personally. I don't have a use for that world anymore. I used to run a massive Rails cluster. I'm good. I did that. Do you have any tutorials breaking down existing app serverless using Arc? Yes, we do. If you go to arc.codes, that's kind of like the main website, and there's all these guides on all these different things that you can do. Yeah. I think that's it. I think we did it.